um 240 search a 2D matrix. Let's see. Write an efficient algorithm that searches a value target, okay, in an m by n matrix. Okay, this matrix has following properties: integer in each rows a row are sorted in ascending left to right, integer in each column are sorted in ascending top to bottom. Okay, so two things to notice here, right? One is the rows are sorted and columns are sorted in from top to bottom, and another thing is we have to search something. So when we search, we can do two things: um, linear search, right? Or if we know that the input is sorted, we can do binary search. Yeah, so I think and they are asking us to write an efficient algorithm, so this is kind of a this has to be a binary search kind of algorithm. But for binary search, we like most of the time we have just a single row, right? So let's see one one way I can think of it is like checking from starting from first row, just do the binary search on this row. Okay, then if it is not here, then go and do binary search here. So for this example, we are searching for 5 and it is found. Okay, and so let's say we are searching for 5.5 something, which is not in this matrix. So we go here again, we do search. Now we come here. Now from this point on, anything you don't even have to binary search, right? Because 5.5 is less than 10 and it's not never going to be in between this range, and same for this. So that's one thing, doing binary search. And maybe if even reduce it from top, right? So let's say it was 1 1 1 1 1 1 everywhere, here 1, then there is no point in searching in this row as well, because 5.5 is greater than this value, right? So we can do that. Is there anything else that I can think of? But let's go through the our checklist. Int matrix. Okay, we have integer matrix, kind of list of list, and we have a target value to find. And what is the output? Do we need to return the index or return true or false? Okay, so boolean is what is expected, true or false is expected. That's fine, that's fine. About the size, so is there a possibility that this is an empty matrix? No, it's not. So always there is going to be one element at least, and at max it's going to be 300. It's cool. And the values, about the values, so these are the two properties. They are sorted, but I just wanted to check if we can have duplicates. There is a possibility of duplicates as well. So, and we also have negatives. So we have negative, we have 0, we have positive, and we have duplicates. Great. Now let's see, test and edge cases row design, code time space. So is there any edge case? Maybe just one element that says S case. Other than that, there are like multiple cases to be tested, right? So target not in matrix. Target is less than start, greater than end, something like this. So these can be test cases. Going further, let's try to come up with an algorithm. So first algorithm that I'm thinking of is a binary search algorithm doing on each row, but I think there has to be something else, because both of these, they are sorted. So let's go through this example, right? What we are searching for is 5. Okay, so let's see. I'm here, and let's say I am checking if it is in between this range. Okay, I have solved this question before, and I think there's a kind of solution where we, so let's say so 5, right? 5 can be in this row because it is starting from 1 and ending at 15, right? So what we do is we decrement. In that case, we go from this end to this end. Okay, so what we are doing is we decrement the column. Now in next iteration we again check if matrix of this is 5, no, then again if not, and if value is less than this value, then we decrement the column. So again we check here, still not, so value still, target is still less than this value, so again we decrement the column. So now we have reduced all this. There is no possibility that anywhere in this section there can be a 5, right? So now our search space becomes this much. So now we check at this location, is it 5? It is not. Is 5 less than this value? It is not. So that means 5 cannot be in this row anymore, because if we go in this direction, it is going to be less than 4 always, and we have decided that there is no value in this section. So in that case we have to go down. So there is only one possibility that the value can be remaining in this section or this whole section. Let's say so we go here and this we find it here, but let's say we are searching for 6 again. We do the same thing, we ignore these values. When we come here, right, we check, is this value equal to 6? It is not. Is this value greater than 6? It is not. If it was greater than 6, then we could just decrement the column. So it is less than 6. That means we have to increment the row. We should go in the next row and check if this value equal to 6. It is not, so we go here, and now it is 6. Again, let's take one more example. We are searching for 3. We start at this position. So 15 is greater than 3, so we decrement the column. 11 is greater than 3, so we decrement the column. 7 is greater than 3, so we decrement the column. 4 is greater than 3, so we decrement the column. Now 1, for this value, 1 is less than 3, so we increment the row. 2 is less than 3, so increment the column. So 3 is found, and if it is not found, right, then either we decrement the column which goes out of bound, or we go out of bounds on the rows. So in that case we return a false directly. So I hope I was able to talk it, because I didn't draw the things, but somehow I think we can do this in this way. So let's see. Let me take rows and columns. So length of matrix is going to be rows, and length of matrix of 0 is going to be columns. We have to find target, right? And let's have two values, row and column. So let's start at row 0 and start it at the last value, right? Okay, so row 0 and column is columns minus 1, length of columns, yeah. And so let's see, while a row is less than total rows and columns is greater than or equal to 0, right, do one thing. If matrix of row comma column equal to target, then return true. That's the only case we can return true. Otherwise, if matrix of R comma C, right, this value, if it is greater than target, then we have to decrement the column. So let's decrement the column -1, else increment the row, right? That's the binary search kind of logic. And if we go out of bounds, then return false. So time complexity wise, it's going to be m plus n at max. Let's say we are searching for 31, right? So in that case, yeah, even it is not m plus n, because we just increment the rows and then we yeah, I think it's m plus n, that's it. So let's see, okay, it's working. M plus n, and we don't use any extra space, so that is constant. Oh, I've solved this multiple times. Okay, nice. Bye bye.